So the next topic in projectile motion is called range. Now you might be wondering what that means. Well, whenever you launch an object at an angle and it flies through the air and lands on the same level, the range is the total distance that is traveled. So it's basically your delta x. So to calculate this is a really easy formula to remember. Range is equal to your initial velocity squared times the sine of 2 times your angle theta divided by 9.81. So let's take a look at an example of this. So let's say that we have a soccer player that kicks a ball at an angle of 40 degrees with a initial velocity of 10 meters per second. We want to know how far will the ball land? What is our range? So our range, we're just going to input our velocity and our angle into the formula. So we have 10 squared times the sine of 2 times 40 over 9.81. Now when you're calculating this, remember you have to make sure that your calculator is in degrees, because if it's in radians, you're going to be getting different answers. So 10 squared is 100. Sine of 2 times 40 is 80, all over 9.81. Now, if you were to put this into your calculator, so 100 times the sine of 80 is going to give me 98.5 on top. And then the final division, 98.5 divided by 9.81, will give me a distance of 10 meters. And that is how you would apply this formula. Now you might be asking me, Megan, yes, this is great and all, but what if I don't have my angle? Well, then we'll do a different example. So let me just quickly erase all of this, and then we can do a different example. This time we're going to be looking for our theta. So we're going to be given our distance, our range, and we are going to be given our velocity, but we don't know what the angle is. So a ball is kicked from the ground with a initial velocity, so VI is 60 meters per second, and an angle theta that we do not know, and it reaches a spot on the ground 200 meters away. So for all of you in Megan's physics class, this is example, or this is question 53A in your homework package. So we want to figure out what the measure of this angle is. And the way that we do that is we would have to isolate for our theta in this formula. So let's put in our numbers. We have 200 meters on this side. Then we have 60 squared sine of 2 times our theta, which we do not know, divided by 9.81. So let's isolate. So we're going to take this number, 9.81, bring it over here and multiply it with the 200. So 9.81 times 200, whoops, 9.81 times 200 is going to give me 1,962. Now 60 squared is going to give me 3,600 sine of 2 theta. To get rid of this number here, we're going to divide both sides by 3,600. Divided by 3,600 is going to give me an answer of 0.545. Now, when we're trying to isolate for sine, we need to bring this over. It becomes sine -1 of 0.545 to theta. This will become, and again, remember, make sure that your calculator is in degrees. So second function sine of 0.545 is equal to 33. Now the last step, I'm just going to bring this up over here, is we need to divide by 2. So 33 over 2 is going to be equal to theta. 33 divided by 2 will give us 16.5. And that is how you would isolate for your theta. So this is how you would use the range formula. I hope this was helpful to you, and I will see you tomorrow.